Welcome back to Algebra 1. Here we go. Chapter 8-2, Distributive Property, but with a little bit of a twist. You know how to go from this to this, but now we're going to look at going from this back to this right here. So let's go. So first off, let's look back over Distributive Property. Whenever my screen decides to change. Loading, loading, loading. And sometime later, we are back again. It finally loaded. Alright, so using the distributive property, we know we have to multiply 3x times 4x and 3x times 3, and that gives us 12x squared plus 9x. So we've already done that. We know how to do this. Now, what if we start with the 12x squared plus the 9x, and we want to factor this out? Alright, well, one thing we can do is we can factor each term. We just practiced that, factoring each term. Now we're going to look at the terms and say, what do they have in common? Well, they each have a 3 and an x. So now I can pull those out. Pulling them out means dividing by. I can divide each of these terms by 3x. And if I divide this by 3x, it leaves me with the 2 and the 2 and the x. If I divide this by 3x, it leaves me with the 3. So if I pull out the 3x, what's left is 2 times 2 times x plus 3. And then if I simplify that, that gives me 3x times 4x plus 3, which is what we started out as. So that's how we go backwards. Basically, the reverse distributive property. We now, instead of putting this into the parentheses, we pull it out of the parentheses. Okay. Let's look at this example. I can always factor them all the way down, but sometimes we can recognize what numbers go into each of these. So I have 27y squared and 18y. You might recognize that 3 goes into both of those, or you might even see right away that 9 goes into both the numbers, and each of them have a y also. So I can factor out 9y. Now divide each by 9y, and what am I left with? This gives me 3y, and then 18y divided by 9y is 2. And there I've factored out 9y. Okay, here we have a larger polynomial, and we'll go through and check to see what do they all have in common. Okay, well, every one of them has a 2. Now, I could factor out a negative 2 because these two are negative. If I factor out a negative 2 here, this just becomes negative. So that would give me 2 positives. So factor out the negative, and then I have an a in each one of them, and a b. So now we'll go through and divide each by negative 2ab. Gives me 2a for this term. Gives me 4b here, and then finally negative 1 for my last term. All right, factoring by grouping. Sometimes not all of them have something in common, but maybe a couple of them have something in common. And remember, if we're just adding them all, it doesn't matter how we arrange them. So I could group them and have the first section here, 4qr plus 8r. Look at these, see, do they have anything in common? And maybe these have something in common. So between 4qr and 8r, I can factor out 4r, and then I'm left with q here plus 2. Out of these two, I can factor out a 3q. So plus 3, sorry, not 3q. I can only factor out the 3. Leaves me with q plus 2. Now notice what happened here. Both of these parentheses are the same. 4r is being multiplied by q plus 2, and 3 is being multiplied by q plus 2. That means they both have a common factor. That common factor is q plus 2. So now I could factor out q plus 2 from each of these. Once I factored that out, that means dividing by q plus 2, I'm left with 4r plus 3. So q plus 2 is being multiplied both by 4r, and q plus 2 is being multiplied by 3. So now I have my factored polynomial factored down to 2 binomials. Okay, factoring by grouping here, we'd look through and see, okay, there's an m here and an m there, but no m's here, so maybe these two might have something I can factor. Okay, so I'll group those together and say, okay, they both have a 2 and an m that I can factor out, so 2m. And then see what we're left with. We're left with k minus 6. Over here, I could factor out a 7. Okay, so I have plus 7, factor out maybe a positive 7. That would leave me with 6 minus k. Now, these two expressions are not the same, so that's not going to help me here. So maybe I can rewrite this. If instead I factor out a negative 7, then I'm left with negative 6 plus k. Well, that's still not quite the same. However, in this case, I can rearrange this. Negative 6 plus k is the same as k minus 6. As long as the sign stays with the number, I can move them around. Remember, that's commutative property here. So now, notice these parentheses k minus 6 and k minus 6 are the same. So 2m is being multiplied by k minus 6 and negative 7 is being multiplied by k minus 6. They have a common factor and I can factor that out. So k minus 6, and then what I'm left with, times 2m and minus 7. All right. Remember, zero product property, if we have something times something else and that equals 0, what do we know about this? Okay, if you know a times b equals 0, think about it. What do you know? You know that one of these, at least one of them, has to be 0. Right? Because anything times 0 gives me 0. So either a or b, or even both of them, are 0. All right? So we need to know this, and we need to use this rule in the next section. All right, we're going to solve this equation. Here we have two sets of parentheses. And this is like my a and my b. Something times something else gives me 0. So I know either this one has to be 0 or this one has to be 0. Or they could both be 0. So that's my a, my b. I want to check. If b equals 0, then that means that x plus 3 equals 0. If a equals 0, then x minus 2 equals 0. So I have two situations I have to look at. Okay, so we're going to solve two different equations for either a being 0 or b being 0. So then here I add 2 to each side, x is 2. And here I can subtract 3 from each side, and x is negative 3. So in both instances, either when x is negative 3, then the entire expression would be 0, or if x is 2, the entire expression turns out to be 0. So there are two solutions. Solutions, another term for a solution when we're talking about functions, is also called zeros. There are two zeros. All right, solve this equation. Again, we have two sets of parentheses multiplied that give me 0. That means either this one is 0 or that one is 0. So split it up into two cases and solve each case individually. So subtract 6 and divide by 2. We get d is either negative 3, or I go over here and solve this one. Add 15, divide by 3. Either d is negative 3 or d is 5. Now, if you run into something like this, c squared equals 3c. Well, I can't divide by 3 here because this is squared. Okay, that wouldn't help me. I can't do the square root because this one doesn't have an exponent. So there's another strategy. I can move the 3c to the other side by subtracting it. Then I get c squared minus c equals 0. Now I know here I can factor something out. Okay, what do both of these have in common? Both of them have a c. So I can factor out a c, and then that's c times c minus 3. Now I have a multiplication, and I can use the zero product property. Either c is 0 or c minus 3 is 0. So then if c minus 3 is 0, then c is 3. And ladies and gentlemen, that's about all the fun we're going to have today. We're coming in right at 10 minutes. Remember to like and subscribe to the Mastermind channel.